Good morning. I'm really excited to talk to you today about build technology for a couple of reasons. One is once you understand how build technologies work and start to introduce them into your workflow, you're going to find that you have made a quantum leap in your ability to develop software quickly and efficiently. Second reason I'm excited is because I just recently found a reading, a link on the web to an article about build tools and an insight into kind of the fundamental philosophical differences between them. And so I'm going to talk about that a little bit in this lecture and also give you a link to the reading that you can use to explore this idea in more detail. So what we want to do today is basically just two quick things. One is understand why we want to use build and packaging technologies. I'm going to give you an overview of a half dozen or so of the modern build tools that are out there, and then introduce this notion from this reading that I came across about the fundamentally different types of modern build systems. And I'm going to talk about them as being declarative, domain-specific languages versus syntactic sugars. So we'll see more about that in a minute. But first, it's probably useful to spend 30 seconds talking about what we mean when we say build. Okay? The build process is not about programming, really. It's about once you've finished programming, writing code, you want to assemble the correct sources together depending upon the environment you're in. So, you might have different libraries depending upon your operating system. You might want to compile or provide certain pre-processing or post-processing depending upon the hardware that's available on your system. And you may want to do different things depending upon your application requirements, tune the system that you're actually trying to create in different ways. Once you've figured out what sources and resources you're going to use, you want to transform them into executable code. And as well, you want to be performing quality assurance on the software. That means maybe running tests to make sure it's actually satisfying the requirements, doing analyses on the source code, on using control and data flow analysis to look for potential defects, maybe doing performance analysis and so forth. And then finally, assuming that it passes all the tests and the compilation was successful, you want to package this thing together, either so that you can immediately run it on the system that you're using, or so that it can be distributed for others to use. Okay, so that's kind of in a nutshell what we mean when we say we want to build a system. And as you can see, that consists of large numbers of steps, large numbers of dependencies, lots of kind of parameters that need to be tuned and so forth. And if you go through that sequence of steps may actually involve many minutes or hours even of total time. And so to have someone step through and do that manually is really time consuming, and quite early on, people realize that really we should have a tool to make this process easy. You just kick off the build and you go off and do something else, and all those steps are going to be done in the correct order every time. So when you think of build technologies, you're really thinking about two kinds of folks that really benefit from them. One is the installer, okay, who is neither a developer nor a user. He's really the system administration, the person in the middle that's supposed to kind of maintain your environment. And so they're not going to bring up Eclipse and do that kind of stuff. They want something basically at the command line or independent of any particular development environment that they can use to accomplish the build steps. Second thing is, by having a build tool, it vastly speeds up the process for developers and reduces mistakes, okay? Which is, in a sense, reduced. And because you can do these build steps automatically, particularly things like invoking tests, the cost of quality assurance is reduced, which means you're more likely to actually do it, which means you're more likely to have a higher quality system. Okay, so all build tools implement this idea of dependency management, but dependency management is actually kind of an overloaded term these days. So I want to really highlight two different uses of the term dependency management, because you're going to come across them both. The first level of dependency management is this idea of what I call file dependency management, and it's the idea that the classic example is the idea that if your source code is newer than the binary associated with it, then you need to recompile your source code. Okay? If the binary is newer than the source code, then you don't have to you don't have to compile it, and so you can save a lot of time when doing the build, just with that simple notion that we don't need to recompile everything. We just need to recompile the pieces that have changed. That's file dependency management. Another level of dependency management in that same genre is the idea that in order to do the tests, you have to have the system compiled, so there's a dependency there, okay, amongst different tasks during the build. All build tools implement those levels of dependency management at kind of the file level. There's another level of dependency management which is become very important as systems are increasingly kind of component based, where they employ a lot of third-party libraries. Okay, and that's called library dependency management. And the idea is that you want to build a system, your system uses a certain library, that library depends upon another library, which depends upon another library, and the versions of all these, various libraries are changing over time, and the dependencies of one version of a library on another version of a library can change dynamically. So that can be quite complicated simply to manage those dependencies, and if you update one library in your chain, which one of those other libraries also needs to be updated in order to maintain compatibility. And we call that library dependency management, and that's a feature of more modern build tools. Okay, so let's take a look at things. The first one that you need to know about, the seminal build tool, implemented by Stuart Feldman in 1977. He won the ACM Software System Prize, very prestigious prize, for this particular tool. And many people regard this tool as one of the fundamental advances in software engineering as a whole. Okay, so it's super important. Called Make. Also, over 35 years old, this tool, still in use today, very, very common, used thousands of times a day. Okay, so how many programs can you think of that 35 years later is being used daily and is extremely common and successful? Make is one of those, very small number of tools like that. Okay, and the idea of Make, it implements this idea of file dependency management and task dependency management. Originally implemented for Unix and still most popular on Unix. There's some porting to Windows, like Cygwin and stuff, but really it's a Unix-based tool. It has this horrible configuration file syntax where tab characters are syntactically significant. It's super bogus. But one of the things, but one of the notable features with respect to this presentation is that the language that you're really implementing is just a shell script. So you're implementing a shell script where pieces of shell command blocks are kind of composed into tasks which can depend upon each other. So you have the full power of Unix at your disposal when you're using Make. Okay, here's an example of a Make file. So you declare these targets all hello, and so forth, and they depend upon each other, and you use a tab to indicate the shell commands that you invoke when you're trying to satisfy a particular target. Okay, so pretty simple and extremely powerful. Okay, our next tool is called Ant. Ant is probably the most popular build tool for Java systems, and Ant came across quite by accident. Actually, the implementers of the Apache web server needed a way to kind of build the system, and they hacked together this tool where they had this XML, kind of configuration file syntax. And what happened was they realized that they kind of stumbled upon a pretty nice paradigm for compiling Java-based systems. So they split out that code into its own project called Ant. Nowadays, Ant is probably more popular than the Apache web server, if you can believe that. Maybe not. But it's quite popular anyway. And the language, however, that you'll see that you kind of write things in is XML. Okay, has a lot of built-in support for Java development. There's some help, some support for other languages now, but really it's mostly Java oriented. And then there's this other system called Ivy, which goes beyond the file-based dependency management, which is supported in Ant natively to provide this library level dependency management. So here's what a build.xml file looks like in Ant, and you can see lot of angle brackets. You've got this XML file. You've got these XML elements called targets. There's a top-level element called project and interior elements called targets. And targets can have dependencies. You can see like the compile target depends upon the init target, and the dist target depends upon the compile target. And then inside you can call little tasks like make dir and jar and so forth. Okay, so you don't really have full access. It's not like shell or like make. Okay, you don't have full access to some underlying, environment or language here. You've got this specialized little domain-specific language which provides these relatively small number of predefined things called Javac and jar and make dir, and the control flow is kind of decided for you by the Ant system itself. If you've familiar with Prolog, for example, it's that kind of thing. Okay, so people, after a while of using Ant, some people started to realize, Ant is pretty cool, but you've got to specify a lot of things. Like, for example, you can see here, you've got to specify the location of your source directory, the location of your build directory, the location of your distribution directory, and so forth. And that's a kind of a design pattern that reoccurs frequently when you do Ant-based build systems. And so the Maven guys got together and said, listen, let's go in a different direction. Let's try to build upon Ant to take it to the next level. Okay, and the idea here is that we're going to make a bunch of assumptions about the way we think most Java projects, are organized, or at least should be organized, and then we're going to build a lot more information into the tool. We're going to make the tool a lot smarter about how Java development works or software development works, so that people can get a lot more done with a lot less configuration. Okay, so Maven is really more than just build technology. It's almost project management technology, and you've got plugins or the ability to generate documentation and reporting. It has this library dependency management as well as a library repository management system. Okay, the user level language, as so to speak, is still XML, and you'll hear a lot with respect to Maven this idea of convention over configuration. So Maven's big selling point, some people view it as a feature, the Maven people view it as a feature, other people kind of are starting to view it as a bug. But their big idea is convention over configuration. So they're going to build in assumptions over lots of things about the workflow of software development, the file layout structure, how things ought to be in most projects, and you can override those default assumptions with greater or lesser amounts of difficulty. But by default, you're going to have a bunch of things. There's the kind of the Maven way. Okay, so here's an example project object management. I forget, pom.xml file. That's the top level file where you define a project, and you can see it. Again, it's XML, and there's a lot of XML in there. But you can see things like you specify the group ID and the artifact ID, and what kind of packaging mechanism. That's a jar file or an ear file or a war file, whatever. And then you specify these dependencies, and you can see in here that we're going to specify that JUnit. This system depends upon JUnit version 3.8.1 for testing. And kind of one of the cool things about Maven is that it will go off and find this JUnit library and download it automatically. Okay, so one of the big things that Maven did initially, which people really liked, was this idea of you could specify the dependencies of your system on other systems, and then you wouldn't have to manually go out and install JUnit before you could get started. Maven would just do that for you. Ant has kind of caught up to that with this Ivy, kind of sibling system, and so the Ant-based builds can do that as well now. But Maven was the first with this. Okay, so I want to kind of call out that the user level language for both Ant and Maven is XML. XML is not really a very human-friendly language, and it's also doesn't have control structures or anything like that. So it's language is kind of in air quotes there. But the more fundamental idea is that we're specifying a declarative, and by declarative I mean we specify what we do, not how we're going to get it done. Domain-specific language, okay, where these targets, the Ant tasks have specific kind of predefined primitives that you can use for the build process. Okay, and so if you want to kind of extend Ant or Maven beyond the set of primitives that they provide, you have to write a plugin which is a kind of this API level specification, and now you got to dive down and understand more about the internals of Ant and Maven in order to make your plugin work correctly. Okay, so now let's go to a whole different way to think about build systems, and Rake is the first one that I want to look at. This is the build system for Ruby and Ruby on Rails. Perhaps you've heard of Ruby on Rails. Very popular and very powerful web application development environment. Also has this convention over configuration idea, but not necessarily when it comes to the build system. Okay, so the idea of Rake is that they just wanted to, they didn't want a whole DSL kind of thing. They just wanted to add a little bit of what I'm going to call syntactic sugar over the programming language to enable it to function effectively for builds and do the kinds of file and task level dependency management that you'd like. So really, when you write a Rake file, you're really programming in Ruby, okay? And that means that the entire power of a general purpose programming language is available for you to use. Now that means that maybe writing these Rake files are a little harder initially. On the other hand, when you try to do more advanced things or things specific to your particular situation with respect to the build process, it's not that hard because you just got a regular programming languages to express it in. So here's an example Rake file. And if you know Ruby, this is just kind of basically regular old Ruby, and it shows how you can compile some C code with it. Okay, Builder is now taking the ideas from Rake and saying, but the Rake file is really associated with Ruby, but we like this idea of having a general purpose build system. Why don't we take that and apply it to Java? And so now we've got this build system that again has this general purpose programming language, which is Ruby, but it has a lot of built-in support in these libraries for Java and Maven, and even Maven file structure. So here's an example of a build file which is used with Builder, and again you've got this Ruby syntax, and it's got these primitives like compile.with and support for file and library dependency management and so forth. So kind of an interesting thing, again trying to get away from this notion that that with Ant it's hard to kind of build in customized logic. With Maven they make too many assumptions for some people about the way things ought to be. So let's try to keep the good parts but have this general purpose programming language for when we need to do something crazy. Well, the problem with Builder in some sense is that if you're a Java programmer, now you got to learn some Ruby. Okay, well why can't we just use Java and as our underlying build file syntax? And if you're interested in that, then the closest thing to that is really the Gradle tool, which is a build tool that is based conceptually on build systems like Rake, like Builder in that it's focused on Java development, but the underlying user level language is Groovy, which is a kind of a dynamic version of Java, but which shares most syntactic details with Java. So it's very comfortable for people who are familiar with Java to use. And again, it builds in kind of compatibility with the layout and basic structure of Ant and Maven projects, so that the transition, if you're a Maven programmer, to Gradle is pretty easy. Here's an example of what a Gradle build file looks like. I mean, it doesn't look that much like Java, but a little bit more than maybe Ruby. Got the curly braces and so forth. Okay, so in contrast to Ant and Maven, we've got Rake, Builder, and Gradle. Okay, though that kind of family of build tools are not attempting to provide a domain-specific language for builds. Okay, where there's a certain set of primitives and a predefined workflow and a certain way of kind of running through the build process. But instead, kind of not the downfall, but the cost of that particular approach is that now you're trying to, you have this general purpose programming language which is a little bit more complicated to learn. It might be syntactically a little more complicated, that you're going to use to do your builds. Okay, as a result, there's little need for kind of plugins for these environments, because you can just simply write your Ruby code or your Groovy code in order to get the job done. So this is the great build divide. It's not my great build divide because it actually comes from this reading, Why Everybody Eventually Hates or Leaves Maven. Okay, and so the notion is, on the one side you've got these declarative build languages, environments like Ann and Maven. On the other side you've got programming languages with a little bit of syntactic sugar to support the build process, like Make, Rake, Builder, and Gradle. And the idea is not to say that one is any better than the other, but really that they provide different kinds of strengths and weaknesses. So the great benefit of using Ann and Maven is that you don't have to learn a general purpose programming language. The syntax is in some sense much simpler, and having this convention over configuration means that, you know, when you're starting up, you can get a lot farther, a lot faster, quite frankly, using one of those tools. So there's a higher learning overhead, I think, with these other tools. On the other hand, once you start to reach the point in your build process where it's become so specific that you're trying to do things that Ann and Maven really don't want you to do, then it's generally easier to implement those very specific features of your build process in Make or Rake or Builder or Gradle than it would be in Ann or Maven. Okay, so what we're going to do in our class is we're going to use Maven for this semester, basically because I do want you to get farther faster. Okay, and I don't want to have this kind of devolve into learning Ruby or Groovy this semester. Also, I think it's really interesting to have some experience with Maven and these DSL-based build technologies, because there's nothing wrong with them. There's many projects out there that use Maven for building, and so by having some experience with Maven, you're not going to feel stressed out about employing those packages. And I'm pretty sure that we're not going to run up against those idiosyncrasies which make using Maven difficult. At least I'm keeping my fingers crossed. Okay, thanks a lot. Let's move on to looking at Maven in more detail.